All right, you guys, we've made it to the last lesson of Unit 4. We are going to do more graphing today in linear equations with our y equals mx plus b, but we're learning a second way to do it, which is with a table of values. So, as we are doing these, you might want to have your calculator handy for this part because we're going to need to type in some stuff, but your linear equation, remember, is the same that we've always had. So that part's going to stay exactly the same. So we've got y equals mx plus b. We all know that m stands for our slope. B stands for our y-intercept. Slope happens over and over again. Sorry. And y-intercept is a one-time deal on the y-axis. Okay? The important part for this is to know this little guy right here, that points on the line are solutions to the equation itself. And we're going to talk about that here in just a little bit. So the important part about this lesson is to know that there's more than one way to graph an equation. Okay. And I want you to know multiple ways to solve different things so that you don't freeze up and only learn, if you only have one way and you've forgotten that one way, then you're not going to pass the test. But there's more than one way to graph. And this is also a way to check to make sure that your graph is correct. We always have had times in the past with our equations where we can take a number and plug it in to see if that answer is correct or not. And this is going to allow you to do the same thing with your graphing. Okay, so we're going to talk about plugging in a table of values for x and y. Now, I know that you can look at this and graph it just by looking at it now after we did lesson 4.4. So this is the second way. And yes, you're going to have to be able to do both of these when you take the test. So it's important that you pay attention and do these along with me as you go, okay? So I have some steps up here. We're going to make a table of values. So I've already got your table started for you. You're going to plug in x to get y in the equation up here. Okay, and then we're going to plot the points we get, and we're going to check our answer based on what we would have gotten had we graphed it the regular way. So these are the 5 values that I always want you to use no matter what, unless you have a fraction. And we'll talk about that for just a minute, or in just a minute. So the 5 values I always want you to focus on to get started are -2, -1, 0, 1, and 2. That's going to give you some things on both sides of the axis so that you have a line that continues. And it kind of gives you some positive and some negatives there, 0 in the middle, just a nice little balance of numbers to use. Now, if you have a fraction for your slope, we'll talk about that in a minute. It's something special that you have to do differently. So we are literally just taking these x values and plugging them in for x up here in the equation to see what we get for y as our answer. And that's what we'll write down on this side of the table. Okay, so here's what it would be. I'm going to start off right now. I've got -2. X is going to be -2 plus 1. So here's my equation. Y equals -2x plus 1. I'm plugging in these values for x in the equation, and then we're solving to see what we get, okay? So for this first part right here, I've got -2 times -2 is 4, and 4 plus 1 gives me 5. So there, I'm going to write the answer. Let's drop down and do it again. -2 times -1 plus 1. This gives me 2, and 2 plus 1 is 3. Okay? Then I'm going to plug in -2 times 0 plus 1. This gives me 0 plus 1 is 1. -2 times 1 plus 1 would be -2 plus 1, which is -1. And then -2 times 2 plus 1 would be -4 plus 1, which is -3. Okay, so I just took that equation, I plugged in all the values on this side for my x, and then I solved it and gave my answer for y in this column over here. Okay, so now I'm going to actually take these and plot them like they're ordered pairs with a little comma here in between them. So negative 2, 5. Remember, our x goes first in an ordered pair and then the y. So now we're kind of reversing what we've been talking about with our slope. We're going to do x and then y like we did that very first lesson. Negative 2, 5 would be left 2 and then up 5. 1, 2, 3, 4, 5. And here's my point. Negative 1, 3 would be left 1, up 3. I'll get rid of these so they don't get confusing here. Okay. 0, 1 would be 0, up 1. 1, negative 1 would be right 1, down 1. And 2, negative 3 would be right 2, down 3. Now, notice that all my points make a straight line, like they should. If you have points that are zigzagging all around, we know we've done something incorrectly. So I'm going to draw my straight line in. I'm going to have arrows on both ends. Okay? Now, to check and see if you've done correctly, you are going to graph this guy again, like we know how to from the earlier. So my M would be negative 2, my B would be 1, I would be starting at 1, well looky there, our y-intercept's the same, and slope would be negative 2 over 1 to make a fraction. Well, that means I'm going to go down 2, right 1. So start at your intercept, down 2, right 1, right on top. Down 2, right 1, right on top. So this is the same exact line that I just made using my table. That's how you check to make sure that it works. Okay? All right. Next one. Here we go. Y equals 3x minus 2. Okay, so same 5 points that we talked about last time. So negative 2, negative 1, 0, 1, and 2. And I am going to put those values into this equation and see what I get for y as my answer to go on this side. So here I go. 3 times negative 2 minus 2. So I'm taking this value and plugging it in for x where it should be. That gives me negative 6 minus 2 is negative 8. 3 times negative 1 minus 2 gives me negative 4 minus 2 is negative 6. 3 times 0 minus 2. 0 minus 2 is negative 2. 3 times 1 minus 2. 3 minus 2 is 1. 3 times 2 minus 2. 6 minus 2 is 4. Okay, now let's go and get these graphed. So negative 2, negative 8, like an ordered pair here, like we talked about. Negative 2, negative 8 would be left 2, down 8. Put a point. Negative 1, negative 6, so left 1, down 6. 0, negative 2. I think I skipped one. Okay. Then I have 1, 1, so right 1, up 1, and then right 2, up 4. Now, you should see that something looks a little off here. So, I'm going to say that this guy looks a little weird, right? That he doesn't right fall where he's supposed to. So I'm going to go back and see. That was this answer right here. Let's see if we did our math right. So 3 times negative 1 is negative 3. Minus 2 should be negative 5. So right there I can tell that that one was wrong because it didn't fall where it was supposed to on the line. Okay? I knew right away. So I should have left 1 down 5. Now look, they all fall in line like they're supposed to. We get a nice straight line going there. Okay? Now again, if you were to switch over and graph this like we talked about, My m is 3. My b is -2. That would mean I'd start at -2 on the y, right on top of where it already is. And my slope would be 3/1. So up, 1, 2, 3, right 1. 1, 2, 3, right 1. And they fall right on the same exact line as I already have. Okay? All right. So I told you that if the slope was a fraction, this would be a little bit different. So in class, when we're talking about this, I had you kind of go through and test this out using the -2, -1, 0, 1, and 2. And we quickly found out that when we plugged this into here, it gave us a yucky decimal. And we don't want to try to graph decimals over here on the graph because that would be crazy. And we wouldn't like the answers we got. So when we're doing fractions for slope, you have to multiply by something that will eliminate the fraction. And if you remember correctly, it needs to be something that goes well with that denominator because we want to cancel out that denominator. So when you have fractions, you need to multiply by something that is a multiple of the denominator. Okay, so if the denominators of 3, the multiples of 3 are like 3, 6, 9, 12, and so forth, right? So if we just want a few of them, you always want to use those first two. So instead of doing -2, -1, 0, 1, 2, we're going to do -6, -3, 0, 3, 6. So you'll notice that when you take this guy times the number that it is multiple of, it cancels out. And you can use your calculator here, but these are going to cancel, and this is going to become -2. So 2 times -2 is -4, and then -4 minus 6 gives me -10. Let's do it again. 2/3 times -3 minus 6. These are gone, and you get -1. So this gives me -2 minus 6, which is -8. 2/3 times 0 minus 6, well, that would be gone completely, and this would be -6. 2/3 times 3 minus 6 would cancel. 2 minus 6 is -4. And 2/3 times 6 minus 6, this would be a 2. 2 times 2 is 4. Minus 6 is -2. Okay, so let's graph them. -6, -10, oops, would be left 6, down 10. -3, -8, so left 3, down 8. 0, -6. 3, -4. And 6, -2. And they're all in a nice straight line. Perfect. Okay. We just have a couple left. Oops, sorry. All right, so I have -1/4 x plus 7. Again, another fraction. So if we look at this one, we're going to have, sorry, trying to get my colors here. We're going to have another fraction, and we want numbers that are divisible by 4. So again, if we think about 4, we would have 4, 8, 12, and we just need those first two. So I'm going to do the negatives first, 0 in the middle, and then repeat again with the positive numbers. All right, so let's plug it in. We've got -1/4 times -8 plus 7. These are going to cancel and give you -2, which is 2 plus 7, and we've got 9. Okay. -1/4 times -4 plus 7. These cancel. Negative times negative is a positive. And we've got 1 plus 7, which is 8. Negative 1/4 times 0 plus 7, that's completely gone, which is 7. You notice these patterns happening every time. This is 9, 8, 7. So hopefully when we plug these in, it should be 6, 5. If you look at the ones up here, oops. If you look at the ones up here, when we had things, we had 8, 5, 2, 1, 4. Those are all 3 apart. 10, 8, 6, 4, 2. Those are all 2 apart. So it starts to repeat a pattern here that you should notice right away as well. So we've got negative 1/4 times 4 plus 7. This would be negative 4. Negative 1, plus 7, which is 6. And then negative 1/4 times 8 plus 7. This would be 2, and negative 2 plus 7 is 5. So those work out. Okay, so let's graph these points. We've got negative 8, 9. So left 8, up 9. Getting tired. Negative 4, 8 is left 4, up 8. 0, 7. 4, 6. And 8, 5. Okay, again, you know it's correct when it gives you that nice straight line that Mrs. Heron can't seem to draw tonight. All right, moving on. Perfect. Now, automatically you should be saying to yourself, this is our special case. This is different. It's a y equals with no x. So this is a hoy. Now, you should be telling yourself right here, well, if I put numbers in right here, there's not even an x up here to plug them in for. So I can't do anything, which means that y is going to be negative 3, negative 3, negative 3, negative 3 every single time, no matter what I try to put in, because there's nothing there. So if I go on y and say negative 3, that's down here. And y negative 3 is all the way across here, right? If I'm always punching a negative 3, it just automatically makes its own line, which is a horizontal line for your hoy. And it's easy to see right there. Okay, which brings me to my next one, x equals 2. So you should be thinking about this. Once again, if x is 2 and there's no y here, if I'm plugging in 2, 2, 2, 2, 2 every time because x is 2, there's nothing that even goes over here. So we're never going to have that y value. It can be whatever it needs to be. So for my x, I need to have 2, which means it's always 2, 2, 2, 2, 2, 2, 2. No matter what you put here, it's always going to be 2 when you bring out for x. And that means it's our vertical line. So it's a vux. Okay? All right, good job, you guys.